So as we continue to graph exponential functions, all that we've added is this number in front of the exponential term that we're going to refer to as the a value. Nothing changes with how we're going to go about graphing these. Okay, but remember that a value is a different amount above the horizontal asymptote than what we saw previously. Okay, so when we go and see an equation that's exponential, we'll first focus on is it increasing or decreasing. Okay, well the base here is greater than 1. So since the base is 3 and greater than 1 tells me that the graph increases. The horizontal asymptote after the exponential term, that would be negative 7. Okay, so y equals negative 7. I'm going to fill in that horizontal asymptote right away. And remember, our graph is all going to be above that horizontal asymptote. We'll have nothing below it. We'll get really, really close to the horizontal asymptote. Okay, but we'll never actually touch it either. Okay, so to get our points, we're going to plug in 5x values. We'll always use the same 5x's, those being negative 2, negative 1, 0, 1, and 2. And we're going to plug them into the equation exactly as we see it. So 2 times 3 to the power of x minus 7. So how we're going to type this into the calculator? It's the exact same. Okay, because we already have a habit to put the base in parentheses, we're going to be good to plug this in exactly how we had gone over it previously. Now again, I'm going to go really slow. I'll explain every button that I press, so if you don't catch it the first time, pause for a second and pay attention the second time. If you don't get it the second time, pause for a second and catch it the third time. Okay, I'll explain it really slow for all these. So here we go. I'm going to plug in an exponent of 2, but I first have to do this 2, which we'll just immediately type the 2. Then our base, we put that in parentheses. So I go open parenthesis, 3, close the parenthesis. Now I'm going to press the exponent button. Exponent button being diagonal from the number 7. That's the caret button. And we're going to pick an exponent of negative 2. Make sure you're using the negative button, not the subtraction button. So minus 2. Then we need to get outside of the exponent. So I'm going to hit the right arrow key. Now we need to subtract 7. So now I'll use the subtraction button and subtract 7. Remember, it gives it to us as a fraction. That's not very helpful. We can now press the button where the arrow is going in opposite directions, where it'll change it into a decimal. And we get negative 6.7. And relax, relax. Okay, I describe this as like my dog, like whenever somebody knocks at the door, my dog barks. He can't help himself. He's a really good dog, but if he hears that bark, he goes crazy. You are like my dog when you see 6.7. You can't help yourself. It's just blurts out. And it's like a habit or an urge that you just can't control. At some point, you'll get over it. Probably not anytime soon. Okay, but negative 6.7. Okay, get over it. All right, here we go. Next one. Again, I'll go really slow. If we didn't catch the calculator buttons, follow along this time. See if we can't get it to match up with me. Okay, so starting with 2. Then open parenthesis. Then the base of 3. And we'll close the parenthesis. Then I'll press the exponent button. That is diagonal from the number 7. We're going to make our exponent negative 1. Then hit the right arrow key so that we are outside of the exponent. And we need to subtract 7. Make sure you're using the subtraction button. Again, it gives it to me as a fraction. That's not very helpful. I'll hit the button where the arrows go in opposite directions. And I get negative 6.3. Again, I'll explain one more time really slow. If we're not getting these values, do your best to keep pressing buttons just like I do. Starting with 2. Open parenthesis. Base of 3. close the parenthesis, exponent button, exponent of 0, right arrow key, minus 7, and I get negative 5. Okay, next one. 2, parenthesis, 3, close parenthesis, exponent button, exponent of 1, right arrow key, subtract 7, and I get negative 1. One last time. 2, open parenthesis, 3, close parenthesis, exponent button of 2, subtract 7, and I get 11. Now that we have our 5 points, we can plot them, and hopefully when we connect them, we see that they increase as they go to the right. So negative 2, and then negative 6, and a little extra, so fairly close to negative 7. Negative 1, and negative 6.3, so a little less than where we were previously. 0, negative 5, 1, negative 1, and then 2. 11 takes us slightly off the graph. That's okay. And then just make sure when we connect these, I'd still just estimate where it would be, yeah. And then make sure when you connect these, you're still showing the tail. Okay. Any questions so far? Okay. I'm going to do number 6. I'm going to go a little bit quicker with my button pressing on the calculator, and hopefully what we start to pick up on is this will go quick once we're really good at pressing the buttons. Okay, but until then, it does take some time. That's why it's so important that we continue to try to follow along and that you are doing the button pressing yourselves. Okay, number 6. My base, or the term that is being raised to the power of x, is 1/4. 1/4 is between 0 and 1. Tell me that this graph decreases. We have a horizontal asymptote. The horizontal asymptote is that number that shows up after the exponential term, and it's y equals negative 10. We will immediately fill in that horizontal asymptote at negative 10. Okay, so it's just the very bottom of this graph here. And now we'll create our table using the same x values as always, being x's from negative 2 to positive 2. And we're going to raise it to the power of, or we're going to plug it into 3 times 1/4 to the power of x minus 10. So only difference here is how we're going to type in the fraction. Remember, all fractions are division problems. So we'll put the division inside parentheses and go from there. I'll explain this first one really slow. Then I'm going to go pretty quick just to get to these y values a little bit more efficiently. Okay? So 3, open parenthesis, 1 divided by 4, close parenthesis. Exponent button, which is diagonal from the number 7. We want the exponent to be negative 2, so you have to use the negative button. Then, right arrow key, and subtract 10, and we get 38. That is really big. We will not even try to fit that onto our graph. Okay, that's way too far. So on to the next one. 3, open parenthesis, 1 divided by 4. Exponent button of negative 1. Right arrow key, minus 10, and I get 2. 3, open parenthesis, 1 divided by 4. Close parenthesis. Exponent of 0. Right arrow key to get out of the exponent, subtract 10, and I get negative 7. 3, open parenthesis, 1 divided by 4. Exponent button, exponent of 1. Subtract 10. Ooh, it gives it to me as that fraction. I can press that button that converts it from a fraction to a decimal. I get negative 9.25. And then the last one, 3, 1 divided by 4, exponent button, 2, right arrow key, subtract 10. It gives it to me as a fraction, so hit the button that converts it to a decimal, negative 9.81. All right, now we can plot these and come up with our graph. So negative 2, 38, that's too big. We won't even worry about that. Negative 1, comma 2. 0, negative 7. 1 and negative 9.25, so a little bit below negative 9. And then 2 and negative 9.81, a little bit further past that. And we should show that it's getting really close to the horizontal asymptote and creating that tail. All right. I want you all to try 7 and 8 on your own. Really important that we try this, okay, that we are getting used to the calculator portion of it. While you're working, I'll come check in. If we have individual calculator questions, I'll help you right now. Okay, but we all need to try the next two problems. Y values for number 7 are 10, 2, negative 2, negative 4, negative 5. Make sure when you connect your points that you're still showing that the graph gets horizontal at the asymptote, showing that tail of the graph. Again, it's never going to get below the x or below the horizontal asymptote. It just gets really, really close to it. Okay? Number 8, y values are 1.75, 2.5, 4, 7, and 13. Okay, if you don't want to graph the 13 because it's a little bit too far off the graph, that's fine. Again, I just kind of estimate where it should be. Does not need to be perfect, though. Right? And then the other things, 8 is increasing because the base is greater than 1. 7 is decreasing because the base is between 0 and 1.